Hello all, once again welcome to PhysiDive, and in today's session, in today's class, we are going to study about the dimension analysis of class 11. So once again, this is your teacher Alexi Rajan and this is our channel PhysiDive. So let's dive in straight to the class. Dimension analysis. In this 11th standard chapter, dimensions, we need to know about the definitions first, and then we need to know about certain words, terminologies related to dimension. For example, dimension formula, dimensional equations, and why we are using dimensions, and what are the limitations of dimension. We will see all these things in this class. Two types of units are there in the physical world, and the first one is fundamental unit, and the second one is derived unit. Fundamental units are the independent units. They are the independent units, whereas the derived units are dependent. They are dependent on this fundamental units. So how we can explain with some examples. For example, mainly there are 7 fundamental units in physical world, but we are in this session, we are going to take only 3 main fundamental units, and we are going to derive how these fundamental units will help us to make new units or the derived units. In today's session, we are going to study about 3 main fundamental units, and the first one is mass. Second one is length. Third one is time. So these 3 units are independent in nature. They don't have anyone to explain or define their existence. So they are staying in a independent fashion. They are staying in an independent fashion. So now these are the 3 units which we are going to see or which we are going to take in this session. So for example, what do you mean by dependent unit then? Dependent unit means, or otherwise derived units. So derived units has some examples I will say. For example, velocity. You all know what is velocity. Velocity means from the small class onwards you are studying this velocity, right? So velocity is displacement by time. Displacement by time. So you can see that thing, it is displacement by time, or otherwise displacement means what? The change in position. Or if I'm saying speed, it is distance by time. Distance means what? Length. Okay, we can say that thing, these all as length. So length by time. So you can see 2 fundamental units are involved here. 2 fundamental units are involved here, and we are defining that speed or velocity with the help of this independent units or otherwise fundamental units, and we call it as a derived units. This is a basic of this particular this particular session. So now we are going to define what do you mean by dimensions. What do you mean by dimensions? Now the definition of dimension goes like this. They are the powers to which a fundamental quantities are to be raised. For example, if I'm saying a mass, if I'm just taking mass, then how I can define, how I can represent mass in dimension form? We can say that mass can be represented as a capital M with a square bracket. Now I'm saying length. Length can be represented as capital L with square bracket. And what is time? In dimension form, we can say time can be represented as T with a square bracket. Now, we are going to represent almost all the physical quantities in terms of this M, L and T, and we are saying that these are the dimensions of that particular physical quantity. For example, I'm taking velocity. I'm taking velocity. So velocity, you know that thing, it is displacement by time. So displacement is nothing but the length, right? Change in position. But change in length is called displacement, and we call it as what? Change in position. I must say that. And change in position is nothing but the length. So dimension is L. And now time. You know that thing, dimension of time is T. So you can say that thing in a numerator way, we can say L T raised to minus 1. But in dimension method, we are representing any physical quantities in terms of M, L and T. But here there is no M, but still we can write this as in this form also. M raised to 0, L T raised to minus 1. Now just see the definition. You can see that any fundamental quantity, any fundamental quantities, it is a power to which any fundamental quantities are to be raised. So here the physical quantity velocity is represented in terms of the fundamental quantities m, l and t with certain powers there, that is m raised to 0, l raised to 1 and t raised to minus 1. So here I hope that you got the definitions right now. For example, if I'm saying that if I'm taking acceleration. So what do you mean by acceleration? In 9th standard, we have learned about a very important equation, that is v minus u by t. From there, we got the equation v is equal to u plus at, and v minus u is what? This represents what? Velocity. This represents velocity. So velocity by time. Velocity by time. Now, we say acceleration can be represented with the help of fundamental units, that is velocity by time. But here velocity is not a fundamental term, but I can represent velocity in terms of fundamental way, fundamental units, that is velocity is nothing but m raised to 0, l t raised to minus 1 divided by t. This is the dimension, right? But t can be raised to the numerator, so you will get a is equal to m raised to 0, l t raised to minus 2. Here you can see the definition. With the help of definition, you can just correlate here. So m raised to 0 and acceleration is represented with m, l and t with certain powers to it, right? So here ml t raised to minus 2 is the dimension of acceleration. So I hope that you got the point. Once again, you must understand that they are the powers to which fundamental quantity are to be raised. And we are representing each physical quantities or physical units in terms of the fundamental quantities m, l and t, and we call it as dimension. Now, straight to the next session, that is, what do you mean by dimension formula? Dimension formula have the same physics or story behind dimension itself. So it states that dimension formula of a physical quantity states that what all fundamental quantities are present in that particular physical quantity and what are the powers raised to that particular fundamental quantities, and we represent this in a form and we call it as what? Dimensional formula. By the definition, we can say it is an expression which shows what all physical fundamental quantities, what all fundamental quantities are to be raised and present, or to represent that particular derived quantity or that particular physical quantity. For example, if I am just taking from the basics, that is velocity, the same example I am taking again, that is velocity is displacement by time. So here you can say that thing, displacement is nothing but L and T, and you will get it is L T raised to minus 1, and more precisely I will write m raised to 0, L T raised to minus 1. And same way acceleration, we got it in the previous session, that is m raised to 0, L T raised to minus 2. Force is what? A derived quantity. It is not fundamental quantity. We are getting force from certain fundamental quantities. For example, the basic equation of force is what? Mass into acceleration. Mass into acceleration. So you know that thing. What is mass? How I can represent mass in terms of dimension? That is m. And what is acceleration? Just see the above expression. You will get m raised to 0, L T raised to minus 2. From there, I will get it is m raised to 0 plus 1, L T raised to minus 2. Why I am saying 0 plus 1? You know that thing, a raised to m into a raised to n is equal to a raised to m plus n. You know this formula? You know this thing? From the mathematics, you will get this formula, and now applying the same thing here, you will get that is m L T raised to minus 2. So now comes the dimension formula of force. So you got a new dimensional formula for force, and by the definition, it is an expression. Force, it is an expression which shows what all fundamental quantities are involved here? What all fundamental quantities are involved here? M is there, L is there, T is there with certain powers. And what all powers are there? To express this derived unit force. And now coming to next thing, that is impulse. Impulse you will study in the coming classes, but I will say with an example, that is impulse is force into time. Force in one. This is the impulse. So you get a new thing. And here in impulse, what all physical quantities are involved? That is M is there, L is there, T is there with certain powers. And now if I'm saying work, what is work? Work, I can say the basic equation is force into displacement. Force into displacement we get, it is M L square T raised to minus 2. Here all you are defining, you are just taking the derived quantities and you are saying that what all physical quantities are involved here, what all physical quantities are involved here, and what are the powers raised to that particular corresponding physical quantity. And we call it as what? Dimensional formula. If I'm saying there are many dimensional formulas there, and I'm just giving you one small homework, that is, what is the dimensional formula of L? L is nothing but it is a linear momentum. Linear momentum is mass into velocity. Mass into velocity. You know what is the dimensional formula of mass? It is a fundamental quantity. So M. And what is velocity? V. You know that thing. You have seen that thing, and you just equate, and you will get the answer. Now, what do you mean by dimensional equation? The physics behind dimensional equation is same as that of dimensional formula. You know that thing, an equation means an equal sign will be there, definitely, and one LHS will be there, and one RHS will be there. And you know that thing, the RHS will be the dimension formula itself, and we are representing LHS as a quantity, the physical quantity, and we are representing that physical quantity in dimensional way or dimensional fashion. For example, if I'm just taking area, then area is what? Length into breadth, right? Breadth is what? It is a representation of length itself. So L into L, that is L square. What is volume? Volume, you know that thing. Volume is what? Area into height. And you know that thing, area is what? L square into height. It is L, that is L cube. But here, in just see the LHS, you will see that thing, area and volume is there, right? We are going to represent that area and volume in dimensional fashion. We can say, instead of writing area, we are representing this area as what? In a square bracket, A, that is L square. Now, we are representing volume as V, it is L cube. And for a force, in the previous session we have seen force. Instead of writing FORC or force simply, we are representing that force in terms of F in a square bracket, or that is equal to what? ML T raised to minus 2, MLT raised to minus 2. So here you are getting an equation there instead of simply writing force is equal to so and so. So we call it as what? Dimensional equation. So that's it for today's session, and I hope that you got the points. And next session we will come with a new topic, that is why we are using dimensional formula and what are the uses and what are the different limitations. So stay tuned and support with your like, share and subscribe. So goodbye. See you in the next class. Thank you.